Good evening. My name is Olasupo-Ojo, and this is my lab report for the second lab. This uses the same experiment as the first lab, in which we check the excess charge of a clear piece of tape after interacting with another one where they're both similarly charged. The equations we used are as follows. We have the electric field of a point charge equation, the gravitational force equation, the electric force equation, the law of equilibrium equation, in which we set the sum of the gravitational force and electric force, which are the only feasible forces in this case, to be equal to 0, in which they have the same magnitude. We also have the electric field of a small piece, which is dE, and we also have dQ in that equation, which is charge of the small piece. And we have the net electric field of an object, which is basically the sum of the pieces that make up the object, the electric fields of those pieces that make up the object. So now let's move on to the data. So as we determined that the charge of the tape is positive due to the pen test. In my variation, my tape B's length was equal to 23.5 centimeters. Its mass was 0.235 grams. It levitated when tape A was 1 centimeter away from it, and the gravitational force was negative 2.305 newtons. Its electric force was 2.305 newtons, and this satisfies the law of equilibrium as when we add them up, they'll be equal to 0, but they have the same magnitudes. So let's move on to the updated model from Lab 1. On the left, we have a picture of two functions. We have the electric field function and the line charge function. The electric field function takes in a charged particle in the observation location, and it plugs out electric field. Whereas the line charge function takes in an object, its start position, the mass, the charge, its axis, how many pieces it wants to create, and it returns an array of values, which contains all the pieces which come with their own charge, their own mass, their own starting position, and their own sphere that represents them. In this slide, we show code up top that represents the two tapes. We have the top tape, which is tape B in this case, or the tape that's levitating, and we have the bottom tape, which is tape A. They're both equal to a variation of the line charge function. They're all the same, so they both have the same charge, they both have the same number of pieces that they want to create. However, the top tape starting position starts 0.01 at the y coordinate to represent the levitation distance at which it started levitating. In this code, we have the dQs, the net electric field, and the net electric force. So the for loops calculate each electric field caused by the bottom pieces on the top pieces. So for dQ in top tape, and then for dQ in bottom tape. So what it does is it calculates the electric field of one dQ from the bottom to a top, and then it adds it to the net electric field, creates an arrow, and proceeds onwards. So after we go through the for loops, we get the net electric field, we calculate the net electric field, and we also create the net electric force as well. And by the end of the code, we have an arrow representing the electric field and the gravitational force arrow as well, and the gravitational force. As we see here, we see two pictures, one from Lab 1, one from Lab 2. We determined the charge to be 1.49317 times 10 to the 8 to negative 8 coulombs in the conditions that we ignore the air resistance and the tapes have the same amount of charge. Here are the additional questions. So what if the tapes were modeled like a single point charge as we did in Lab 1? Then we get 1.59965 times 10 to the negative 7 coulombs, compared to the 1.49317 times 10 to the negative 8 coulombs. There isn't that much of a difference, as it differs by a factor of 10. And why do these estimates differ? It's because in the Lab 1 chart, from Lab 1, we represented the tapes as 1 point charge, but in Lab 2, we represent them as 10 charges. And the more charges we get, the more accurate we get, the much closer we get to the actual electric field value. So we can say that the charge from the Lab 2 is probably going to be much closer to the real value than Lab 1. Thanks for listening.